Hey, good afternoon and welcome back. This is JR at Trade Skillers Anonymous. And just recently I posted a short talking about cheap CNC bits versus a higher quality CNC bit. And so today is going to be the follow-up for that bit, and what we're going to talk about primarily is through the lens of a relatively new user. That would be me. I've only had a CNC machine for about 9 months. I've learned a ton along the way, and I just wanted to take a moment and share with you through my very novice, my experience level, what I've found along the way, what was important to me in the type of work that I did, and hope that you might find it useful as you continue to get yourself used to life with a CNC. So let's get into it. Okay, so yesterday I took the liberty of preparing this piece of plywood here, and all I've done to it is just some half-inch plywood. All I did was threw some black paint on it in the hopes that as I made a few cuts, it would help to illustrate, the cleanliness of the cuts. So today what I hope to do is use this board to demonstrate the difference between an upcut bit, a downcut bit, and a compression bit, or what's also referred to as an up-down bit, which has cutters that are in two different directions on the same bit. So what I'm going to do is put this on the machine after a brief explanation of just what some of the basic differences are, things that I think I would have found helpful information about 9 months ago. As you can see here, I've got a plethora of bits. Many of them do exactly the same thing. But while I was, waiting for my machine to come and getting ready for the arrival of that machine, I had some spare time. So, did a little looking around, some shopping, and, honestly, I've found myself with a good number of bits that I just really don't use. So again, if I can help anybody in the future not repeat that same experience, I feel like it'd be a good day's work. So thanks for coming along. I appreciate it. Okay, so first I thought it might be useful to just get through a little bit of core knowledge first. And so the first bit that I have in my hand is called a downcut bit. And what that means is that as the router or your spindle turns in this direction, if you can follow the flutes on this bit as they turn, you can imagine that what it's going to do is it's going to cut the material and then throw the chips or push the chips down. And the down is really in reference to away from the router itself. Okay, so then the next one up is going to be an upcut bit. And so again, as you watch the flutes on this cutter turn, and this would be the direction that the router would be turning, you're going to notice that those flutes would carry away or carry upward towards the router your shavings or your material that you have cut away. So that's going to evacuate those chips out of your workpiece. And then these are two examples. These are two examples of, now they're the same size, 1/4 inch diameter, and these are compression bits. And I have a tendency to think that this gray one is going to be easier for you to see on camera. So this is a Whiteside bit, and the reason it's going to be easier to see on camera is that this is an up-down or a compression bit. And what you'll be able to notice is that at the very end of the bit, there is an upcut portion. So you can see, if you can imagine that bit was turning, the bottom cutters of the bit are going to be pulling the chips up. But if you look up the bit in this area, you'll notice that as you turn the bit in the same direction, this whole portion of the bit is down cutting. So that's why it's called an up and down cut bit, or a compression, because it's going to cut in two different directions simultaneously. Now I'm going to throw into a picture-in-picture environment here so that you can see that not all bits share the same geometry. And so this is a Whiteside. This is a it's called a UD 2102, the UD meaning up down. And then this is a Jenny bit, is the name of this particular bit, and it's made by Cadence Manufacturing. And he's a fella who also owns the same machine that I do, and is a pretty good guy. And you know, I love that entrepreneurial spirit. So what I'm going to point out about these two different things, and if it helps, I may end up just blowing this up full screen. The upcut portion of this particular bit is roughly 250 thousandths deep before it transitions into the downcut. And this bit, by comparison, again, same diameter and same geometry in that they both are up-down bits, but the upcut portion of this bit is only 100 thousandths of the first part of the bit is the upcut, and the remaining 900 thousandths of the cutting area is a downcut. The reason that is important to know how much of your end of your mill is the upcut portion is that this bit, as an example, well, let me say this. Most people are going to tell you that if you're running a 1/4 inch end mill, then your depth of cut should be somewhere around 50% of the diameter of the bit. So in this case, that convention of thought would tell you run this bit at no more, or the comfortable area would be 125 thousandths depth of cut. Well, because the upcut portion of this bit is, or better said, the downcut portion of the bit doesn't start until past 250 thousandths, this is going to act on your first cut exactly like an upcut bit. And there's nothing wrong with this bit. When I run an aggressive cut, this is definitely a good bit to use. But this bit, the advantage that I think it has, because the downcut portion starts only 100 thousandths from the end of the bit, you could run that 125 thousandth depth of cut and still be taking advantage of the upcut portion and the downcut portion on your very first pass. And what that's going to do for you, theoretically, is it's going to help you to have cleaner cuts on the upper side of your material, or the face up side of your material. Whereas the geometry of this bit, you would have to run at least a 250 thousandths depth of cut in order to take advantage of the compression nature of this bit. Okay, in this part of the test board here, I'm setting up with just some simple text and some dividing lines to be able to better demonstrate the test itself, let you know which bit was cutting in what area. And so this is known as a V bit if you're new to CNC, and if that's the reason that you've started to watch this video. And I will cover that just briefly here in a few minutes, but just wanted to show you that we wanted to lay the board out here in a way that would make it easy to understand the test. Okay, and at this point I took a break and had to make a bunch of different tool paths so that the upper portion of this board is being cut at 125 thousandths depth of cut, and the bottom area of the board is being cut at 250 thousandths depth of cut. All the feeds and speeds were the same, 100 inches per minute, and on a Makita router, 2.5 was the speed setting. So whatever that works out to, but I've just found that that's a really consistently good setting for cutting through plywood. So in order, so we're doing an upcut, a downcut, then we're on to the Whitesides, which you can see, you know, had a fair amount of fuzzy, but again, it's because of the geometry of that bit has the first 200 thousandths of an inch of that bit is the upcut, so you really don't get to the downcut until, and I think I just said that wrong, until about 250 thousandths. So if your cut isn't 250 thousandths or deeper with that particular bit, you're not going to take advantage of the compression bit. Now the last one coming up here is the Jenny bit, and it has its compression transition starts at 100,000. Okay, so I purposely left the camera running, except I think I bumped a cord, had to restart it. What I'll point out is that all of the outer border and the letters that you see in here, those were done with a 90-degree V-bit. I will have talked about that before. So this is a 1/4 inch upcut bit. This section was cut at 125 thousandths depth of cut, and everything down here is 250 thousandths. So I would expect to see, because again, as the bit is rotating, the flutes are pulling up the material. This is actually a pretty good cut. Might be partially aided by the fact that it was painted yesterday just to try to produce more contrast, but you can clearly see that there is fuzzies, and I chose this star just so that I had more chances at cutting area. Here is the down cut. So again, to remind us, that is where the let me move this. So that is where the bit is turning in such a and the flutes are arranged in such a fashion that it is pushing the chips back down, not up, hence the name. And as you can see, compared to a little bit of a fuzzy there, looks like a little splintering, but compared to the fuzzies that I see here, here, and here, that's an improvement in the cut. So if I was doing a pocketing pass, this might be one way I would consider doing that. So this one here, you're gonna think for a moment that this bit didn't do so well, but again, what I want to point out, these two are both up-down bits or compression bits, they're referred to. And again, at the end of the mill, it is a upcut, and the rest of the mill is a downcut. But what you're seeing here, and the reason that I thought it would be important to point out, is that when you're buying bits for yourself, it's very important to make sure that you pay attention to the bit geometry. So, and again, this is the bit that I showed earlier. And if the camera will focus, what you're going to see is that at the end of this bit, closest to my palm, you'll see that there's a pretty large area. So this whole section right here is the upcut portion, and then the rest of the bit is the downcut portion. The reason that the geometry is important, again, is that most people are going to tell you that in order to not overload a machine, you want your depth of cut to be roughly half the diameter of the bit. So if that's the case, and you were to run this 1/4 inch bit into your wood 125 thousandths, you're not taking advantage of this area of the bit. This is going to act like a very truncated upcut bit, and you don't get into the downcut portion of the bit until you're already deeper than 250 thousandths. So this is an acceptable cut here, right? But because we're riding on just at 125 thousandths, just that end of this end mill, you see we have substantial fuzzies. So even on this 125 thousandths or 1/8 of an inch depth of cut here, we're already into the compression portion of the bit, where both the upcut and the downcut are engaging, and then this is the 1/4 inch depth of cut here. So just a quick sample and example of that. Not all bits, now this is a very good bit, and I'm not afraid to run this Whiteside's bit deep into even hardwoods, walnut and maple, but I know that the geometry of the bit, and this one is another company, Align Carbide, also an American company, which I'm fond of. You just have to be aware that the bit is arranged in such a fashion that in order to take advantage of that compression piece, you have to be deep enough in your depth of cut in order to take advantage of it. All right, so the other bits that I would tell you are worthwhile looking into are V bits, and so that's how you're going to achieve a lot of sign making or detailed lettering and so forth. They come in a lot of different flavors. So I've got a 15 degree, 30 degree, 60 degree, and a 90 degree. And quite frankly, most of the time I'm using the 90 and maybe the 60. You have to be into some very fine detail in order to convince yourself that you need a 15 or a 30 degree. And honestly, I bought those because I didn't know any better at the time. And I thought, well, yeah, sure, if it exists, I probably should have it. So that's why they're in the toolkit, although they rarely come out. And then for the purposes that a lot of people would use their CNC machine for, so I know a lot of folks make cutting boards as an example, and this is the bit that I would use to make a juice groove. And so it's a cove bit or a bowl bit. As you can see, it has a router, or excuse me, a bearing on it, and that is something that I used on my handheld router when I was using jigs. But you know, this is not going to penetrate into your wood when it's in your router, so that bearing is not in the way and can certainly be used on your CNC machine. And then this is another Whiteside's bit, so you can see it's obviously had a fair amount of use. So this is a 1-inch spoil board cutter, and this is certainly probably one of the first bits that you're going to use, because once you establish a spoil board on your machine, this is how you're going to flatten or surface that spoil board. So that's a good investment there as well. Okay, so before we get too close to the end, there is one very important thing I wanted to mention, and that is that of the failures that I've had on my CNC machine, meaning a project didn't come out right because something happened, every time that has happened, it's been that I've asked the machine to go aggressively enough against the work holding, meaning you're holding it down with tape, double-sided tape, CA glue, screws, nails, fences, and cam clamps, whatever it is. Every time I've had a failure on my CNC, it's been that I failed to properly create a situation where the work was held strongly enough against the lateral forces that are in play when you're asking your machine to do a lot. You know, a lot of these machines, or I should say a lot of the tools, come with some recommendations for speeds and feeds. So if you're new to this, speeds is simply the rotational speed of the bit, and the feed is how many inches per minute you're going to ask your machine to move that cutter through the material. And you know, there's a lot of folks out there that take a pretty aggressive stance on trying to get through a job, you know, especially you know, if you've got a lot of them to do, the temptation is to start pushing the machine and asking it to operate nearer to the outside of its envelope. You know, so 50 inches a minute for a 1/4 inch end mill is way too conservative for me. 200 is too conservative. You know, I'll tell you that I'm comfortable in cutting plywood, you know, at about 150 inches per minute. You know, but I'm going to keep that to maybe 1/8 of an inch, possibly just a little bit more, maybe 300 thousandths per pass. Just depends on the wood that you're working in. But the work holding is super important. You've got to make sure that that piece is fully secured. So I did a short the other day where I talked about, you know, what bits do you need and don't buy these kind of bits. And what I was referring to are the very cheap Chinese bits that you find on online retailers. I, you know, won't worry about mentioning who. The reality of it is that so I've seen a lot of people make the comment that when you're just starting out, to buy cheap bits because you're going to break some. Well, I've only ever broken one bit, and it was completely my fault. I was zeroing my Z-axis and didn't have my probe set up right, and you know, anyway, broke the bit. But my concern with that is two reasons. Number one, if your mindset coming into this is to treat your tooling as a disposable or cheap part of what you're doing, I'm afraid that that's going to create a bad habit that says the tool doesn't matter, so run it harder than you should, or don't worry about taking care of it, or not be careful with it when you're using it. And I think that that's a dangerous way to start somebody's thinking out when they're coming into this CNC arena. And the fact of the matter is that if you've got, you know, an average or above average cost machine, you've got a $3,000 robot in your shop arrangement. And I just don't know why someone would encourage you to use the cheapest possible bit, a dollar or two bit. And the reason that I wouldn't do that is I might have hours and hours of work into creating a panel. So what I do a lot of is furniture. You know, I don't make a lot of signs and that type of stuff, although that's popular and a good use of the machine. It just doesn't happen to be what I do. And I don't use pine and, you know, typically softer woods. So, you know, I'm just afraid that if you start out thinking that, you know, a $2 bit is going to perform for you the same way that maybe a more premium bit is going to, you know, it's really going to take a chance with your project. And, you know, a bit that dulls quicker because it's not, you know, the same quality materials and so forth, you know, that's going to increase. So as the bit can't cut as well and it's traveling through your wood, that's even more lateral pressure coming into your workpiece. And again, if you don't have your work holding secured, you know, that's going to create problems. And I just, it's just not the way that I would subscribe to. So that's one part. And the other part, and I don't care if you live, I know YouTube's an international audience, you know, if you live in Germany, if you live in Canada, if you live in Switzerland, I don't care where you're at, you should have some reason to do business locally. And, you know, I am just concerned as a citizen, and I live in the US, that as all countries put too much effort and energy into having China do all of our manufacturing, and we just become consumers, and we don't seek to find those same products that are available in whatever your home country or your home area is, then I don't feel like I'm doing what I should do to support my local economy. And that's the primary reason that I feel that way. The other thing is, so I did buy some cheaper bits that were made in China. And so I've got a technical background. First part of my career is very technically oriented work that I was doing. So one of the first things I do when I buy bits is I measure them and make sure that as I'm loading them into my software, they are the diameter that I expect them to be. And I learned that lesson. Again, I didn't do it on the CNC, put a cheap bit in there, and nothing I did would allow that bit to hold into the collet correctly. So then I measured it after the fact and found that the bits were undersized. They were never going to work. So, you know, it's a real pain in the ass to return stuff, you know, through an online retailer. You got to go drop it off somewhere and all that. And I just really wouldn't rather do that. I would really rather do business with people in my area, you know, locally owned businesses that I just think it's a good thing to do as a good citizen, and not just here, but wherever you happen to live. So just give that to you for your consideration. So to wrap it up, I hope that you got a chance to see up close, you know, some of these different, the way that an up cut bit cuts versus a down cut bit, and the way that a compression bit works. I hope that that was clearly demonstrated enough for you. And then within compression bits, you also need to be asking the question, you know, how much of the end mill is dedicated to the upcut. So is it the first 100 thousandths? Is it the first 200 thousandths? Because again, the convention for, you know, people giving each other advice on the internet is that you typically want your depth of cut to be about half of the diameter of your cutter. And in some cases, if you do that, you're not going to be taking advantage of the compression nature of some bits, just however, you know, they're designed. So something to be careful of. So I will, on the last part of this video, just mention that none of these bits were given to me. The machine wasn't given to, nothing in my shop is sponsored or affiliated, or I don't have any coupon codes to share with you. I don't have any relationships with anybody like that. And I only point that out because I want you to know that this isn't a biased observation. This isn't something that somebody has asked me to do. This is something that I felt was good information and stuff that I wish I knew 9 months ago, before my CNC showed up, because, you know, I've got a handful of CNC bits that I'm just never going to probably use. And it's because I didn't know what I didn't know at the time. And so I hope that you find this helpful. If you like the video, please give a thumbs up. And if you care to and feel that there's value in it, I ask you to subscribe while you're here. I appreciate you for spending time with me. Take care, and we'll see you soon.